This selection of tapes looks at how we try and understand the dynamics of change. Science fails to understand change in any meaningful way. It can analyse quantitative change well enough, but how things emerge and evolve is less well understood. Jim Schofield's latest philosophical research attempts to address qualitative change and begins to devise new experimental approaches and methods for capturing and understanding these crucial changes as they happen. So, Jim, what kinds of things are we talking about when we discuss qualitative changes, and why can't science currently get a handle on them?
Well, it's not the normal understanding of qualitative at all. It all stems from what Hegel found out a long time ago. And he found out that though much explanation was about quantitative change, there was a kind of change that there was no real explanation about, and that is qualitative change. And in fact, the Marxists came out by making this a kind of basis of their philosophy. They said these qualitative changes, what is called the dialectical leap in change, is very, very important and must be understood. And sadly, that is what science doesn't understand. Nobody does that.
So, I mean, we've talked before about big qualitative changes such as the emergence of life, or the emergence of matter, or the emergence of consciousness. But I get the feeling from the new tapes that not all of these are quite as monumental, that we might be talking about smaller things as well. Is that a fair assessment of the new approach?
Oh, I'm sure that's true. Those that you've just mentioned are, of course, important, but they're built out of these things at smaller sizes, tinier things. And they can be built up into complicated things like consciousness and so on, and thought. But if you don't understand the underlying things, you're not going to get a good handle on the top ones.
Yeah, and I guess, it's really perhaps impossible to devise an experiment that would attempt to understand the qualitative change that led to consciousness. But other changes we might be able to approach, more modest ones, we might be able to approach using an adapted scientific method. Is that something that you've been thinking about with these new tapes?
Well, I don't think I'm anywhere near the higher level processes that you talked about at the beginning.
No.
I think I'm still down with a shovel, down at the bottommost level. But I think that only if this level is understood thoroughly will the big ones be able to be cracked. They'll try and find shortcuts and they'll be wrong. There's no doubt about it. Everything builds up from the bottom. You can't ignore any sort of basis. You've got to look at it, and you've got to understand how it qualitatively changes as you build on it. You've got to. You can't start high up.
So, this does feel like a change in approach. I think we've been talking for ages about the problems of reductionism. But now I think there's also an acknowledgement that one of the main issues with science is that we don't really understand the thing that we're constantly trying to reduce to anyway. We don't really understand that bottommost level of reality. So is this really a question for physics then?
Well, I'm a physicist. That's what I was trained at. And I've arrived at this problem. But I never found any addressing of it in my subject. None whatsoever. Not in physics. The people who tended to try and address this as psychologists and people like that philosophers and so on, but not physicists. No, they never did a thing.
I mean, because physics is one of the more quantitative subjects, isn't it? Everything gets turned into data.
That's its weakness. I mean, you have to do quantitative things, but all the really important ones are not quantitative, are they? You know, all the ones about thought and understanding and so on, they're not quantitative. They're very, very subtle things. I mean, I posed for myself a question. Can we talk about the origin of life using the work that I'm doing now? And the answer is no. Too early, much too early. The origin of life is big, okay, very big. And people who give you discussions of as if they know what was the origin of life are making it up because they don't understand the underlying things that build up into it. I think it's the biggest question of all, the origin of life.
So, what sort of things could we start by looking at? Where could we find qualitative changes that we could potentially investigate experimentally?
Well, the interesting thing is everywhere is the answer to your question. No, really, I'm not being clever. Everywhere. If you take any study, any discipline, and try to get down to the nitty-gritty, you're going to find these things there. People make shortcuts, assumptions that they say they've got from science or from somewhere else, you know, religion or whatever, and then use those. But the only way you'll do anything is by having a sound basis. And that is still lacking, in my opinion.
One of the other things you talk about in the tapes is the problem of the speed that these changes can take place at, and that we often mistake them for being instantaneous because their trajectory is hidden until the last moment, or things are just happening too quickly for us to ascertain them.
Well, I think that's very, very correct, and I'd like to emphasize it in a particular way. One of the things that happens in all explanations, and I put that last word in inverted commas, is they will describe something that's happened before happening again. And my question would be, oh, that's interesting. Why does that happen? And they'll say, well, didn't I just tell you? And you say, no, you just told me how it happened. You just told me this and this, make that. I'm asking you the question, why? They don't ask the question why. I don't know why they don't ask the question why, but they do not. What is called explanation is description, not explanation. It's something that's happened before, and they can see it happening again. They say, oh yeah, I know that. Yeah, that's such and such. But that is not an explanation.
Yeah, I mean, one of the ways in which things are described is that they're broken down into pieces, sampled, things are turned into data, and this often misses the dynamics of what's going on.
It always does, because it sounds final. Once you've got it as a number, you think you've done it.
It removes time from the equation, really. The time that things take, why things take the time they take, how things can change slowly and then suddenly change quickly. All of that temporal information.
Well, I didn't answer your question about speed, and I should do it now. One of the things that I came up with is the change from quantitative changes, which happen with just numeric values changing, to qualitative changes, where you get a change in qualities. Now, people just take that as it is and say, when you get to this point, it becomes that. But that's not an explanation at all. And in my studies, I've found out that's just inadequate. All you're doing is describing events that started out as quantitative and ended as qualitative, but you haven't said why.
Yeah. I think one of the interesting words you use quite a lot is this idea of an avalanche, that everything, the ground beneath your feet almost changes so suddenly that we're completely perplexed by that change. And so we don't try and understand it. We just say, and now we're in situation
Well,
B.
we do. You're right.
So yeah, I mean, part of what this work involves is us. How do we approach the avalanche? How do we understand this sudden, sometimes seemingly catastrophic changes as they happen?
And the problem is what you mentioned earlier about speed. You see, I think all qualitative change, all, not just one or two, all, is an avalanche of changes. It's not a single thing. It's not a flip, right? But it's happening so fast that you think it's a single thing. And even when you say it's a single thing, you can't possibly say why. You say, well, that's when it happens. When you get to this stage, it does that. But that's not sufficient and never should be. The actual things that are involved in all qualitative change are many and varied. It's not a flip. And they get away with murder by just saying, here's the change, and when these changes happen, you get X.
I think one of the interesting things is there's a metaphysical assumption that lies at the heart of this, which is that time is seen as just quantitative. No one ever talks about the qualities of time. And I think this, in the tapes you mentioned earlier, research that you did on dance and motion research, which I think also played with this idea almost of qualities of time. Are we talking of bits of time? Is time continuous? So that's really fascinating. How is the same, perhaps, philosophical approach applicable from dance to science? I think that's a really interesting
Well, it's
thing.
to do with the very, very large variation in speeds of things. If you've got very, very fast changes, you're perhaps not even knowing that they're changes. You think it's a one-off. You think it's a single thing, and you give it a name. But if it's much slower, you can look into it and you can say, notice, it didn't happen immediately. Let's try and find out what the stages were in this change. So people are aware that change can be caused by a series of steps, but only when it's slow enough. If you get a fast change, they think it's a single event. And I'll tell you something, it never is. Never is. A qualitative change is never a single event.
Now, obviously, science attempts to isolate things in order to try and understand them. So it's always removing things from natural contexts. And maybe that's one of the reasons why we see things as single events, because we're so used to having to separate things out into single variables that we're attempting to measure. How can we borrow methods from other areas? For example, Marxism is a common one that we've used. How can we apply ideas from outside science to help us try and understand qualitative change?
Well, the only general way I can think of, it's not philosophical, it's to do with method.
Yeah.
If we do not treat everything as changing over time, everything, and we say that this is this so far and then it becomes that, like a switch, we're never going to understand real change, because none of it is such. All of it involves a process. Every single change involves process. So you've got to change the way you do things, and that means you've got to evolve much faster processes of analysis, very much faster. Some of the ones that I'm coming across in my work are so fast that nobody on the surface of the earth interprets the change as a process. They all think it's an event. Nobody that I've ever met. But it is a process. It's just so fast that no one knows what the content of that series of changes is. But without that, you're not going to understand it.
I mean, the speed that things can change is one barrier. The other one is unpredictability. The fact that we don't necessarily know when a change is going to happen. We can get lulled into a false sense of security by the fact that systems often appear to be stable for long periods of time.
Well, you know why that is? It's because we don't understand the situation.
Well, yeah.
The reason that we don't know what's going to happen is that we don't understand it. We don't know what's causing it. We have no idea of what's happening internally to that situation. What are its motive forces? We don't know. So we just wait until it changes and then stick an explanation on it that we just dream up. It isn't necessarily correct at all.
I mean, is there a kind of dialectical contradiction here that in a sort of Marxist way, that the best way to try and understand why things change is to try and understand why they're stable in the first place, or why they appear to be stable in the first place?
Oh, you do ask big questions. I don't think I can answer that. I really don't. I mean, we all our ideas of stability are inventions, simplifications.
Yeah.
They just make life easier. Do you know what I mean?
Yeah.
And they're not that far from the truth, because things can stay the same for quite a long while. So you can say, well, it's stable forever, you know, and then I can use it as a constant. So it's a big question.
We're here to ask the big questions. That's our job. But yeah, I think so. What do you think the next steps might be in terms of if your team of scientists were here and they said, okay, Jim, what do you want us to look at? What would you advise them to do?
Oh, well, there's all kinds of scientists, isn't there?
Well, that's true.
I mean, as I say, I was trained for many, many years as a physicist. And there's one thing I would go nowhere near in addressing these questions, and that's physics. Nowhere near. A waste of time. The only people who seem to get anywhere are people who look into living things, because there's more change there. You have to go to the people who see change around every corner. They're the people who know what change really is, though most of the change that they see is at a level which is easily recognised. But nonetheless, the mechanisms that happen at that level are likely to be happening right down below, but in in tiny steps.
Yeah.
It's quite very, very fast changes. It's going to the places where people are studying change as a process. That's where to go.
And then maybe using that as a general guide to apply to other sciences. If they're getting close in something like the study of evolution, how can that then be applied?
The only trouble is, in my opinion, and I've been in universities half my life, if you go to someone who's used to a certain way of doing things and you start talking about you've got to do it differently and why don't you do it like them, they get most upset. They don't say, oh, yes, you've got a point there. No.
The biggest barrier to us addressing change is our fear of it.
It is. I'd say you're right.